Let's be real. Almost everything we do today, from sending a text, streaming a movie, you name it, it all depends on this invisible architecture that's wrapped around the entire globe. So today we're going to unpack that system, computer networks. We're diving into the fundamental ideas that make our super connected world even possible. I mean, you've got to wonder, right? It feels like actual magic. You hit send on an email and, poof, seconds later, it pops up on a screen thousands of miles away. Well, it's not magic, but it is a total marvel of engineering. Let's trace that incredible journey your data takes every single time you go online. So, to understand how that email makes its trip, we have to start with the most basic concept of all. What even is a network? It's a really simple idea, but man, it's one that has completely reshaped our world. And it really is this simple. At its heart, any network, whether it's the whole internet or just the Bluetooth connecting your headphones, is just a bunch of devices, what we call nodes, connected by links so they can share stuff. You can think of it like a group of people connected by phone lines. That's it. That's the core idea. So why do we even bother connecting all of these devices? Well, it's for one simple reason: to provide services. I mean, all the things we do online every single day, checking email, browsing the web, hopping on a video call, those are all services that run on top of these networks. The network itself is the how, but these services, that's the why. It's the whole point. Okay, so we've got the what and the why. Now let's get into the nitty-gritty how. If a network is just nodes and links, what does that actually look like in the real world? Let's take a look at the actual hardware that makes it all happen. You can basically break any network down into three core pieces. First, you've got the terminal equipment. That's your device, your computer, your phone. Second, there's the communication supports. These are the actual roads, like fiber optic cables or Wi-Fi signals. And third, you have the interconnection equipment. These are the routers and switches that act like traffic cops for the digital world, deciding exactly where your data needs to go. But, just having the parts isn't enough. It's kind of like building a city. The layout of the roads is absolutely critical. In networking, we call this layout the topology, and the design you pick has a huge impact on how well everything works. Let's check out a few of the common blueprints. First up is the bus topology. Now, think of this like a single party line on an old telephone. Everybody's connected to the same cable. It's super simple to set up, but if everyone tries to talk at once, it gets clogged up fast, just like a one-lane road during rush hour. Next, we've got the star topology, which you see all the time in homes and offices. Everything connects to one central device, like your Wi-Fi router. It's really efficient, but there's a catch. If that central hub goes down, the whole network goes down with it. Then there's the ring. Here, data travels in just one direction, kind of like a message being passed around a circle of people. Each person in the circle repeats the message, which keeps the signal nice and strong. This makes it fantastic for covering long distances at really high speeds. And finally, we have the mesh topology. This is the big one. This is basically the backbone of the internet. The key idea here is redundancy. There are tons of different paths for data to travel between any 2 points. So if one connection breaks, no big deal. The traffic can just be rerouted another way. It's incredibly tough. So we have the parts and we have the blueprints. But with millions of digital roads crisscrossing the globe, how on earth does your email know which path to take to get from your computer all the way to your friend's phone? Well, for that, you need a set of rules for directing all that traffic. There are pretty much 3 main ways to do this. Circuit switching is like an old-school phone call. You get a dedicated, private line for your whole conversation. Message switching is more like the postal service, where your whole letter travels from post office to post office until it gets there. But the internet relies on packet switching. This is the game changer. It chops your email up into tiny digital postcards. We call them packets. Each one finds its own best way through the network, and then they all get put back together at the other end. It's an incredibly efficient and robust system. Okay, but this brings up a huge and maybe the most critical challenge of all. We've got countless different networks all over the world, built with different tech by different companies. How do you get them all to speak the same language so they can cooperate? See, back in the early days of networking, this was a massive headache. Every company built its own system, its own proprietary network, and they were totally incompatible with each other. It was like a digital Tower of Babel. So to build a true global network of networks, an internet, they had to invent a universal language. And that is exactly where protocols come in. A protocol is just a standardized set of rules for communication, a rule book. It doesn't matter who made your computer or your router, as long as they all agree to speak the same protocol, they can understand each other, plain and simple. Now, the universal language of the internet is a set of protocols called TCP/IP, and its genius is that it breaks the massive job of communication down into 4 manageable layers. Think of it like a shipping department. At the very bottom, the link layer is like the truck that drives on the physical road. The network layer is the GPS that plans the best route. The transport layer is quality control, making sure the package arrives in one piece. And way up at the top, the application layer is you, the customer, opening the box. The beauty is, each layer just does its job without having to worry about the others, and that makes the whole system unbelievably flexible and powerful. And this is the ultimate goal of all that incredible complexity. The entire system, the cables, the routers, the different shapes, the protocols, all of it is designed to be completely invisible to you. It's designed to just work so you don't have to think for a second about whether your data is flying through fiber, bouncing off a satellite, or zipping down a copper wire. You just click, and it appears. But it's really important to remember that these rules, these principles, were designed decades ago. As we dive into an era where literally everything from our cars to our coffee makers is connected to the internet, the big question is, are the old rules of the road still enough? What new blueprints, what new languages will we need to build the network of the future? Thanks for joining us for this deep dive.